For those of you who are joining, we'll be getting underway in just another minute or so. We'll just let more people get in. Well, good afternoon. I want to welcome everybody to our virtual event on tile drainage today. This virtual event today, the webinar, is brought to you by Discovery Farms programs in both Minnesota and Wisconsin, and the many organizations that support our programs. Discovery Farms, for those who aren't familiar, is a water quality research and educational program that focuses on the intersection of agriculture and water quality and stresses the importance of farmer leadership. Now, today's event will focus on one project, a recently completed NRCS Conservation Innovation Grant project entitled Developing Diagnostics to Improve Water Quality and Soil Health on Tile Drained Lands in Minnesota and Wisconsin. Today, key lessons learned from this project will be shared, along with how the data can be used in future strategies to meet water quality and soil health goals. I want to thank our sponsors, and you see them listed on the screen there. And as I've already mentioned, our key sponsor for this program specifically was NRCS through their CIG program, along with Minnesota corn growers in Minnesota, the dairy farmers of Wisconsin, and we also want to acknowledge the Minnesota Department of Agriculture, who provides in-kind service funded through the Clean Water Land and Legacy Amendment. So how today's seminar will work. We'd like to have you enter your questions in the Q&A box at the bottom of the Zoom screen. We will not have you turn on your microphones. We ask that everyone keep their microphones and cameras off to save bandwidth and prevent background noise. We will take questions after each speaker, and then at the end of the three speakers, we'll have questions for all three of them. So if you have a question, please put it in the Q&A box. Now, the chat box is also available, and if you are having trouble with the Zoom format or the meeting issues itself, feel free to put those items in the chat box, and we will try to address those as well. A reminder that the webinar is being recorded, and it will be made available at the MAWRC YouTube page, and it also is streaming live on our Facebook page. So if you want to come back and view it later, you're able to do that. So without further ado, we'll want to get right into the data. And so I'll introduce our first speaker. Eric Cooley is Wisconsin Discovery Farms co-director, and he's going to give us an intro to tile drainage and the CIG study. Eric.
Great, thank you, Warren, and good afternoon, everyone. Again, my name is Eric Cooley. Trying to get my slide to go forward here. All right. So again, the overall topic today is improving water quality and soil health on tile drained lands. And I will be giving kind of the introduction for the project and some of the work that we've been doing in both Wisconsin and Minnesota with respect to tile drainage research and monitoring. So the first thing, I know many of you are likely very intimately familiar with tile drainage, but for those of you that may not be, I borrowed a quick graphic from John Panuska that I really think kind of visually showcases the benefits of tile drainage. And we can see on that the far left, on the undrained land, if we have a relatively wet soil or where soil kind of lays high in that soil profile, we can see that when those roots are initially developing near planting time in spring, those roots don't want to go down into that saturated zone. And then when it rapidly falls in the summertime period, those roots are very near the surface and they aren't pulling both water and nutrients from a very large portion of the soil profile. Whereas if you look on the right, on the tile drained land, you can see that if we can bring that free water level down in the spring to a lower level, when those roots are initially developing, they can go much deeper into the soil profile, and we can pull both much more water as well as nutrients from that soil. And we see less drought stress, and we also see typically higher crop yields in tile drain lands, especially in close proximity to where those tiles reside in the fields. Because we're moving some of that excess water, we typically also see improved field access and reduced compaction by drying those soils up quicker in spring. There have been many studies that show how if you have a landscape and that is not tile drained and then do tile drain it, that increased storage capacity of water in that soil profile with the tile drainage will reduce topsoil and resulting nutrient loss with that runoff by having that tile installed from surface water losses. And then finally, in both Wisconsin and Minnesota, this is another important one for us because of our relatively cold climates, is that removing that excess raw water really helps us to get those soils to warm up for germination, for seed germination in the spring, because it takes about 5 times more heat to increase an equal volume of water by 1 degree as it does for soil. So one of the things that we did a number of years ago is that we combined our Wisconsin and Minnesota Discovery Farms data sets. And from the initial 14 years of tile drainage data that we completed from 2004 through 2017, this was a real benefit for us because in Wisconsin, we had all of our tile drainage sites were on dairy manured land. And being able to combine that data set with Minnesota, we really got to see some cash grain, tile drain monitoring, as well as some more diverse farming cropping systems, as well as manure types through their tile research. So it's really been a great benefit to share our data sets and really look across the states at some of the trends that we're seeing in the tile drainage data. So building off of that, in this new tile project, in the last 3 years, we've almost doubled our total site years of data and have over tripled both the number of sites as well as the farms that we've done monitoring on. So we've really greatly increased our tile drainage knowledge in the past 3 years. And this is really what Aaron and Tim are going to focus on in the upcoming presentations. So I'm going to talk about some of that initial data that we collected in those first 14 years. And when we looked at the surface runoff between the two states, it was really similar. We typically saw our first major peak occurring in March during snowmelt, and then we saw a secondary peak in that June time period with those kind of later spring rains. When we look at the Minnesota tile compared to that surface water runoff trend, we see that the peak occurred during that secondary June time period with surface water. So we see it ramping up from that snowmelt that we get in Minnesota in March, and then it peaks corresponding to that secondary surface water peak in June. Then it really rapidly tails off as we get into the summer and growing season. And then we really don't see, at least in Minnesota, much runoff occurring until we get to that snowmelt time period, again in March. Wisconsin is a little bit different story, where our peak actually in tile actually coincides with the surface water peak that we see in March with snowmelt. From that time period, it kind of steadily decreases again until we get into that summer time period where crop uptake is highest. And then we are at our lowest period until we begin to build again in late fall with those late fall rains, as well as some early snow melts with some of that early snowfall in January. And we actually see tile flow in many of our sites throughout the frozen soil period until we get that snow melt in March. So the secondary tile project, again, which we're really focusing on some of the data today, is really to provide 3 main things. We found out from our initial data that we still had quite a bit more to learn about different tile systems and some of the dynamics of those. So it really is to gain additional knowledge so that we can better provide tools for farmers and advisors to diagnose and treat fields with high nutrient loss through those tile drainage systems. Then the second idea, which was actually developed by some modeling that the USGS in Wisconsin had done, is that they thought if we had some of our intensively monitored sites, that we could really complement those by some lower intensity monitoring methods to really get a bigger bang for our buck with some of the intensive monitoring. And then finally, we looked at a number of different soil health metrics and tried to see if there was going to be any correlation between those soil health metrics to some of the tile drainage water that we had monitored. So the way that we did this is that we put in 48 sites between the two states. The first kind of level of monitoring that we had were the intensive sites. And this is commonly the way that we had previously done all tile drainage monitoring in both Wisconsin and in Minnesota, where we had continuous flow as well as continuous sampling of that tile drainage water. And in this first picture that you see there, you can see the refrigerated ISCO sampler that would allow us to take 24 samples. And then that sample line went down into that agar drain where we had a calibrated V-notch stop log that we used for those flow calibrations. So again, at these 8 sites, which were evenly split between Wisconsin and Minnesota, we had continuous flow as well as continuous sampling of those. So then we combined that with an intermediate modeling or monitoring approach where we had continuous flow monitoring, again using those agar drains, but we used a Solinist flow monitor to do that flow measurement, but then we came in and only did a bi-weekly sample at those sites. And again, we had 20 of those sites between both Wisconsin as well as Minnesota. And then finally, we had our bi-weekly sites, or our basic sites, where we did both bi-weekly sampling as well as a bi-weekly instantaneous flow measurement. So then what we did is we took data from all of these different sites, kind of compared and contrasted the strengths and weaknesses of each of these different monitoring schemes, and really tried to figure out the validity of if we have one of the intensive sites that you see on the far left, can we match those with some of these lower intensity monitoring to still get a relatively good assessment of that water? So with that, are there any questions before we move on to Aaron?
I see one question for you, Eric. What is the vertical axis on your chart of drain tile water and surface runoff for Minnesota and Wisconsin? Was that inches per acre or just inches?
That was inches. So what that has done is those basin sizes were divided by the runoff volume. So that would be actual inches of surface runoff or inches of tile flow. So if you want to do a comparison and contrast, that would be on an inch of rain that would fall, you could do that direct comparison on a per acre basis.
Thank you. And yeah, and so they're normalized to essentially an inch per acre then, is that correct?
Correct.
Okay. And then one other question, as long as you've got that slide up, is the difference in peaks between Wisconsin and Minnesota's data primarily a precipitation issue, that you get more rain in Wisconsin than we do in Minnesota, or are there other factors?
So Warren, we're going to talk a little bit more about the secondary set of data that we have that will build upon this. So if we can, let's bring that question to the end, because some of that might be answered.
Perfect. We can do that. And then, and maybe you'll answer this question too, was the Wisconsin flow influenced by warmer climate as you were over near Lake Michigan?
Again, I think we'll talk about some of the differences in flow when we compare this first 14 years of data with the 3 that we just collected, which we're going to see some similar trends.
Perfect. And then could you describe again the difference in flow monitoring methods between the full and the intermediate approach, the difference in between the weirs and the flow meters? Sure.
So basically they were different types of pressure transducers that we used. We used a Solinist pressure transducer in the intermediate sites, whereas we used a bubble line with a pressure sensor in the continuous. So different methodologies, but same basic functions to determine the depth of water. And then we use those V-notch stop logs to calculate the amount of flow based on rating curves that were established for each of those agri-drain sizes.
Perfect, thank you. And then one last question before we move on to Aaron. How was the drainage area determined for the different tile sites, and did it vary significantly by site?
Great question. I will say that it did vary significantly between some of the sites, and we used surface topography to try to define those tile water watersheds. We do understand that there may be some things going on in the subsoil which can change some of those estimates, but based on surface topography and knowing where those tile systems resided in the soil from the installation diagrams, that's how we calculated the watersheds for those subsurface tile systems.
Very good, thank you. And I see Tim Raditz would like to answer a question. Did I see that correctly, Tim?
Nope, I was just marking them as answered.
Okay, very good, thank you. Well, then we're gonna move on. Thank you again, Eric, for your presentation. And at this time, we're gonna hear from Aaron Wonderland. Aaron is the Senior Research Specialist with Wisconsin Discovery Farms, and he's gonna talk about some of the sampling challenges and flow analysis.
All right, thank you, Warren. Okay, yeah, so I'm going to be talking about more of the flow that we saw during this study period. First, I'm going to talk about the challenges we had collecting the biweekly data, some of them anyway. Then I'm going to talk about the flow dynamics between the states, and then the relationship between flow and nutrients. So one of the challenges we had was backwater. Of course, this is caused by rain and snowmelt that causes flooding or drainage areas being blocked so the water can't get away. This was mainly an issue at the basic sites, but we did have a couple of times where at a couple of the intermediate sites where we had backwater as well. In most cases, we could still tell if the tiles were flowing, or even with the submerged sites, we can see bubbles or the water rolling at the ends of the outlets. Another challenge was that winter causes the tile outlets to freeze. As when it gets colder, the ice columns form from the surface up. And at first you can break those away to be able to get in there and sample and take measurements. But over time, they get stronger and stronger and you can't break them away. Eventually it makes it to the outlet and then the ice just freezes around it and in it, and you just can't take samples anymore. And then another challenge is that access can be limited, especially in winter. Snow can drift into the drainage areas and cover up the tiles. Any of the sites that were close to the roads, there's a high potential that snow from the snow plows would bury them. Oftentimes we could dig those out and get in there, but other times we couldn't because things either froze up or because of safety concerns. So now we're going to move on to the flow dynamics between the states. The average flow frequency of the tiles from Minnesota was 43%. And when I talk about the frequency, I'm referring to anytime that we visited a site, was it flowing or was it not flowing? So Minnesota had their highest frequency around 75% at one of the sites. 8 of the sites flowed 50% of the time, and they had one site that flowed less than 10% of the time. In Wisconsin, the frequency was, on average, was 82%. 3 of the sites flowed year-round, 12 of the sites more than 90% of the time. All but 1 of the sites flowed 50% of the time, and the remaining site flowed less than 25% of the time. When we look at the timing and the volume of flow, they are different between the states. This is a graph of just from the study period. And if you remember back to Eric's slide, it complements it very well. So the timing is different and the volumes are different. But, why are we seeing these differences? We looked at the 30-year normals for precipitation as well as the precipitation trends between the regions of the two states, and we found that they were very similar. So that would suggest that there's some other influence affecting, how these tiles flow. Things like geology, whether there's high water tables or restrictive layers and lateral flow, things like that. In Wisconsin, one of the things that we noticed was we're potentially intercepting groundwater. We had a high annual flow rate or flow volume compared to the annual precipitation. And in some cases, we had more volume in the flow than we did in precipitation. And these three sites are kind of the extremes of what we saw, but they're not limited to these three sites. So the volume in the site on the right and the left was about 70% of the precipitation, and then the site in the middle was on average 130% of the precipitation. When we look at the other sites in Wisconsin, it was about 32%, and in Minnesota, it was 23%. So we see that flow dynamics are different between the states, regions, and sites. We can see between the states, the frequencies are definitely different. You could see from the earlier graph, the volumes and timings are different as well. When we look at regions in Minnesota, two of the regions made up one half of this frequency chart. Two regions made up the other half, where in Wisconsin, it was a lot more scattered. And then even the sites within regions were different. Here we had one site that flowed year round, and the other site flowed less than 25% of the time. And then if anyone was curious, the green arrow is the site that was in the middle of the previous slide where we had over 130% of precipitation. And you'll notice that that's not a site that flows year round. So in general, you can't really say that flow frequency necessarily means more or less flow. So now I'll move on to the flow and nutrient dynamics. This is what we typically see in for concentration trends in tiles. We notice that suspended sediments and phosphorus trend very similar. They do have low concentrations much of the time, but we see that periodically we have these big spikes. And these big spikes we have found are related to higher flow. Even though it looks like there's a pretty flat line, with these big spikes, it's a large range, so we can't really say they're very consistent. On the other hand, when we look at nitrate, there is fluctuation, but the range of variability is much less. And nitrate seems to have more of a seasonal effect on variation versus the flow effect. Phosphorus and nitrogen respond differently to flow. This is the hydrograph of one of our sites, and I put a few arrows up to just show different peaks. Obviously, there's a lot more peaks, and I could have drawn more arrows, but that just would have cluttered things up. So when we look at the nutrients, these arrows represent the same areas. Where flow increased, we saw an increase in phosphorus concentrations, but a decrease in nitrate concentrations. And you can see that some of the smaller peaks had bigger changes in the nutrients. Some of the bigger peaks had smaller changes in the nutrients. And there's also the exceptions where we don't really see quite that same trend. And that would be due to other factors that would affect concentrations. So I mentioned earlier about the groundwater, and So how does that affect the concentrations? So these are the Wisconsin sites graphed together. If we were to take just those sites that are groundwater influenced, it would look a lot different. Keeping the scales the same, this is what it would look like. And groundwater dilutes the concentrations and reduces the variability of all of the analytes, and it makes it difficult to do trend analysis. And if we add the hydrograph to one of those, you can see that flow changes are more noticeable than the concentration changes when you get the bigger precipitation events and snow melt and things. So we know that conditions do not always cooperate, and it makes sampling and measuring flow difficult. Biweekly sampling year-round is a good way to get data, but you can expect to potentially miss a few data points. We know that flow frequency, volume, and timing are different between states, regions, and sites. You know, different areas and sites respond differently, and they should be treated that way. And then flow affects nutrients and sediment concentrations differently. For phosphorus and sediment, we see it's more flow dependent, and in nitrate, it's more seasonally dependent. Phosphorus and sediment are less consistent, even though they have those low concentrations much of the time. They have those really big spikes during those bigger flow events. Whereas nitrates are more consistent, there is fluctuation, but the range of variability is much smaller. And then phosphorus and sediment have a positive correlation to flow, and for nitrate, there's a negative correlation to flow. And when we have groundwater interception, that dilutes the concentrations and reduces the variability. So knowing how flow affects these things, if we were to just collect samples or measurements here and there throughout the year or just part of the year, you're really not going to get a good picture of what's actually happening in your tiles. And with that, I can take any questions.
All right, very good. Thank you, Aaron. And so we're going to start with a question that we kind of carried over from the last time. And you talked about the precipitation effects, but this question is about temperature. Was the Wisconsin flow influenced by the warmer climate near Lake Michigan?
I really can't answer that. I'm not sure.
Don't see, yeah, you didn't look at the data for that specifically, perhaps.
Correct.
Next question, you talked about backwater and showed some pictures describing the backwater. Can you describe how you estimated flow rates under backwater conditions? Did you develop a rating curve? Did you try using acoustic Doppler meters?
With the basic sites, we just had a missing data point. We really didn't have a way to do it, or we didn't think about it in order to come up with a way to do it. In the agar drains, I mean, there was only a couple of sites, a couple of times. We just looked at, what would the maximum flow rate of the tile be? And then just once it got to that point where it was backwater, we just gradually reduced to what was after the backwater was gone. And like I said, almost every time we had these backwater conditions, you can see that there was some kind of a flow, so it wasn't just stagnant water sitting over the tiles or just in the agar drains themselves.
Okay, very good.
Can I add to that, Warren?
Oh, go ahead.
Yeah, so Mark, I think that's a really good question, and it's really important that flow measurement is really hard and a difficult measurement for us to get. And so that's where our intensively monitored sites, our regular, really high quality monitoring stations, we do use some like AV sensors or acoustic sensors to get a handle on flow during those backwater conditions. But with this study, we were really looking at more lower cost ways to get some of those measurements. So for the intermediate sites and the basic sites, we know there's a weakness in those sorts of flow measurements.
Thanks, Tim. Next question, was soil water holding capacity determined for all the different sites?
I'm not sure. I know we did some stuff with soil health. I don't know if that was one of the ones that we did. Otherwise, we never, or at least I haven't looked into, you know, what those would have been. I'm sure that that would have some sort of an effect on flow in the tiles, though.
Very good. Thank
Yeah.
you.
So yeah, and we know all the soil types, so we know kind of a water holding capacity of the sites. But and part of this soil health measurements, as Aaron was talking about, was looking at bulk density and some other physical measurements that can give us more insight into that soil water holding capacity.
Very good. Thanks, Tim. The next question, would these groundwater influenced sites be good candidates for drainage water management as a practice? And maybe the question is also, are you familiar with drainage water management? As I understand it, I think the questioner is asking about systems where, like the AgriDrain, when it's used in systems where boards can be put in to limit the amount of water that leaves the field during times of the year.
Right. Yeah, of all of the sites, at least in Wisconsin, only one field really had the right conditions where you could use the AgriDrain the way it was designed. Otherwise, the slopes of all the other sites were too great to really be efficient, I guess, or accurate, or do it very well, if at all.
Sure, sure. Very good. Thank you. Were most of the drainage areas basins for the tile sites in agricultural land use? And can you describe a little bit the different types of ag land use, corn, soybean rotations, corn silage, alfalfa, and so on?
Right. Yeah, all of the sites, from what we could tell, were nearly, if not all, very near all agriculture, or the field that we collected data on. We had some no-till sites, some tillage sites. We had alfalfa. We had corn silage, corn grain, soybeans. We even had like sorghum Sudan, green beans. So we had a lot of different crops that grew on the field. Some of them had manure applications, some of them had regular commercial applications, some had both. So we had a wide variety of different sites to look at.
Very good. Just like we have a wide variety of crops across the states. So thank you for that. Next question. Some of the photos that you showed included a solid wall PVC drain tile with no holes. Can you describe what kind of pipe and perforations or screens are typically used at the Discovery Farm sites? And are there other options?
Well, the PVC that you see is just a piece of pipe that was attached to the actual perforated drain tile, or in some of the cases in Wisconsin, we had some old concrete or clay. And these were all the way. We didn't do anything to these sites as far as changing the outlets or anything like that. So that they were monitored the way they were put in by the farmer.
Okay, perfect. Next question, and this one may be something we'll hold for Tim, but the question is that there is talk about nitrogen concentrations, the correlation to flow, but at some point, would the concern be about the total amount of nitrogen being discharged?
Yeah, I will answer. I'll have a lot of stuff on nutrients in the next segment.
Perfect. Then we'll hold on to that one. Are you able to describe the tile depth and spacing used? Is it similar for all sites?
Right. As far as depth, and of course I'm much more familiar with the Wisconsin sites. I believe all the depths were about 4 feet. Spacing was different. I know we had some, I think we had a couple that had grid tiling, some that had just kind of the random that followed the landscape. But as far as like the definite spacing and that, I can't say off the top of my head.
Sure.
We
Again,
do have the
probably,
data.
yeah, again, it's probably much like the landscape is. There's a lot of different types of systems out there.
Correct.
Yeah, very good. All right, well, thank you, Aaron, and we're going to
Thank you.
move on. And keep in mind, if you have questions for either Eric or Aaron, continue to type them in the Q&A box, and we'll get back to them after Tim. But we're going to move to Tim Raditz. He is the Discovery Farms Minnesota coordinator, and he's going to be talking about the nutrient concentrations and some soil health measurements.
All right, thanks, Warren. Can you see and hear me okay?
Yes.
Awesome. Well, I'm going to talk today about the nutrient side of things and what we're seeing with our tile monitoring, and specifically this Conservation Innovation Grant project. First, I'm going to hit on sort of a big picture of tile and nutrients and use our whole data set from both states over the 15 to 20 years that we've been collecting data, and talk about the differences in surface and tile and nutrients, different nutrients and sediment, so we can really put into context some of the levels of nutrients that we're seeing, and maybe have an idea of what some things are to focus on for surface water and some things are to focus on for tile drainage. Next, I'll be focusing on tile and nitrate and looking at some specific agronomic practices or factors that influenced nitrate levels. And I know there was a question on this prior, but we'll look at some crop types and nitrogen rates and see how that played a factor in some of the nitrate levels we're seeing in the tile. I will also touch on the soil health in tile. We had a soil health component of this grant that I'll kind of summarize at the end. And then the last thing I'm going to wrap up with are a big part of this project was to see how accurate biweekly samples were to like our standard really high quality measurement or high quality flow weighted mean concentrations from our automated sampling. So I'll wrap up with that. So first, in terms of big picture, if we're looking at soil movement, this here's a graph of total suspended solids or suspended sediment measurements across our Wisconsin and Minnesota data set. And each of these points is a sample that has been taken over the last 15 to 20 years. So for surface water runoff, we have over 2,000 samples, and for tile flow, over 6,000 samples that are in these two graphs. So right away, you can see that surface water really can contain higher amounts of sediment than tile flow. Tile flow is relatively clear, doesn't really move that much sediment, even in areas with open intakes. Compared to surface water runoff, tile flow doesn't move as much sediment. If we're looking at phosphorus, which is another nutrient that we're looking at in our Discovery Farms program, same graph here looking at total phosphorus concentration, sample concentration for surface water runoff samples and tile samples on the right. And these boxes are box plots. So the shaded area in between those two lines would represent the middle 50% of the data set. So, and that 1.24 is the median. So 50% of our samples were below 1.24 and 50% of the samples were above that 1.24. So even though we had some samples on the higher end, it's a highly skewed data set, but our median level is right at 1.24 for surface water runoff. If we're looking at tile drainage, that median level drops to 0.06. So we're seeing a lot less phosphorus movement through the tile systems than comparatively to surface water runoff. And this has to do with, well, we see more soil loss, and there's some phosphorus attached to soil, but also the dissolved fraction of phosphorus tends to be more of an issue for surface water runoff than tile flow. There are some higher levels in the tile, get up around that 5 milligrams per liter. If we split this out by state, Minnesota on the left here and Wisconsin on the right, the Wisconsin sites tend to have more of those values in that higher phosphorus range in terms of tile drainage. And I think this has something to do with more surface water connection to the tile systems in Wisconsin, whether it be due to soil types or blowouts or just the general geology and landscape of that area tends to lead to more surface water connections to the tile lines. If we move into nitrogen, this is where the story flips a little bit, where we're seeing more nitrogen, in particular nitrate, move through our tile systems comparative to the surface water runoff. So if we're looking at tile, or if we're looking at nitrogen, we really want to focus on tile flow when we're assessing nitrate movement for our ag fields. Now, if we split our tile sites up between Minnesota and Wisconsin, we can see that Minnesota in general has a higher median than Wisconsin, but Wisconsin has much more scatter of that data set. And I think this has a lot to do with crop type and nutrient types as well as to why we see that higher scatter amount. So we want to focus on nitrate with tiles. So that's what I'm going to focus on next. In different factors that really influence that nitrate concentration. And from here on out, this will just be data that represents the sites from our tile CIG project. So in the last 3 years, 2018 through 2020. And so there's a lot of different factors that influence nitrate concentrations in tiles. But if we're starting at the top, we're going to look at crop type, and we can see that there is some influence of crop type on nitrogen concentrations in tiles. So if we start with corn, we sort of have the highest median, soybean in that similar range. If we move on to dry beans, these would be like dark red kidney beans, things like that. We see a drop in concentrations, and wheat is pretty similar. Alfalfa, a drop even further. And then finally, we did have one pasture site, 3 years of that pasture site where we saw very low nitrogen concentrations move through that tile line. We did have some other crops that just had 1 or 2 years of data. I didn't put those on this graph just to try to keep it less busy. But again, there is some scatter within here, so there's definitely some other factors that are in play, right, when we're looking at nitrate and tile. So if we focus on our corn crop and looking at nitrate values for corn grouped by the previous crop, so the previous crop also plays an influence. So these are just our corn years and breaking them down by previous crops. So corn, this would be continuous corn. This would be corn following soybean. This would be corn following wheat and corn following alfalfa. And we can see there's sort of a decreasing trend where corn following corn, we had the highest levels of nitrate in the tile, and corn following alfalfa, we had that alfalfa kind of has a delayed, it can have a delayed impact on nitrogen movement in tiles as well, to really delay nitrogen movement in that first corn year after alfalfa as well. Now, if we're looking at other agronomic factors, we can also look at nitrogen rate. So again, these are for all our tile sites that were in the corn years, which is our primary crop that we're applying nitrogen to. We group these by 50 to 100 pounds per acre nitrogen total application. In this one, 100 to 150 pounds per acre nitrogen. And so on, 150 to 200, 200 to 250, and then 250 and above. And we can see a gradual step up as we get to go from 50 to 100 to 150 to 200. Again, there's a lot of scatter in there, so there's other factors that come into play, but this nitrogen rate does play some sort of, or does have some sort of impact on that. The 250 and 300 pounds per acre, we only had one site in each of those, which I think is why we're not seeing that same increase in our tile monitoring, because there's many other factors that come into play for those sites. If we're looking at cover crops, we did have a few sites that had cover crops with their corn, or prior to corn being planted, and that tended to have some impact too. These graph on the top is looking at average annual nitrate for our corn sites, and grouped by our nitrogen application rates for that corn. On the top is no cover crop, and on the bottom is a cover crop. And we tended to have some reduction in nitrate, average annual tile nitrate, due to that cover crop for sites that were in similar nitrogen application groups. But again, the data is fairly limited. We really need more data in this area. But from looking at other research throughout the upper Midwest, it's cover crops can play an active role in reducing nitrate losses through tile systems. And lastly, to really break it down further, looking at nitrate values for these corn rears grouped by previous crop and nitrogen rate. So combining previous crop and nitrogen rate really breaks it down even further and gives a more clear representation of the average annual nitrate concentrations. If we're looking at corn following corn, we can see an increase with nitrogen application rate. Corn following soybean, we see a similar increase. Corn following alfalfa, interesting here, we don't have as many sites. We see an increase with application rate, but the increase isn't as significant as corn following corn and corn following soybean. And then lastly, we do have some corn following wheat sites. We did see an increase with application rate as well, but the number of sites we have is very limited. So moving on to soil health and tile drainage. So soil health practices have the potential to improve water quality by increasing that infiltration, water holding capacity, and protecting the soil from erosion. Right, this is a very positive thing, or can be a very positive thing for surface runoff. Our question with this project was, how does that impact tile drainage? And my question in general is, if we're promoting practices and increasing our infiltration, it's good, but is that increasing the amount of water that mixes to the tile? Is that increasing or changing our nutrient cycling within our soil profile that potentially mineralizes more nitrogen and makes it available for movement to tile drainage? Those were some of the questions we were trying to answer. So we measured a number of different things within this project: active carbon, particulate organic carbon or matter, potentially mineralizable nitrogen, and so on. Those were the chemical analysis that we're doing for soil health. We also did some infiltration and bulk density measurements for physical measurements of soil health. The problem and the challenge, I wouldn't say it's a problem. The challenge we had was questions on methodology. So when were we going to take these samples? And we had lots of meetings with our soil health experts here in Wisconsin about this. We came up with taking these samples in June, which we thought would give us the best chance to assess differences between soil health differences between the sites, because in June it tends to be where the microbes are at their most active stage. So our potential to find differences would be greater. The other option would have been pre-plant sort of sampling methodology, but we chose that June time period. Location was also a question for us. So we're typically monitoring tile drainage at an outlet that drains anywhere from 10 to 600 acres. So how do we take one soil health sample and get a good estimate of that drainage area to compare it with our tile water quality monitoring? That was a big challenge for us. The depth was a question, and also sample transport. In talking with Matt Ruark, who is our soil health expert and who did a lot of this chemical analysis in Wisconsin for us, we were told to keep the samples cold, but not frozen. So it's when we're looking at taking soil health samples, all these things come into play, and it's sort of a new area for a lot of folks. So really important to assess all these different factors when you're coming up with a soil health sampling methodology. But at the end of the day, we did not find any correlations between our soil health measurements and tile water quality. And there's a few possible reasons why. Our methodology was insufficient. Maybe we didn't take enough samples, or we didn't sample in the right way or at the right time. Also, our sediment and phosphorus concentrations were low at these tile sites. It's hard to determine differences when we have lower concentrations. But for our nitrogen, I thought that was one area where we might find some differences, but I just couldn't find them within the soil health data set. And I think it has a lot to do with just having too many variables, not enough sites to really tease out the soil health impacts of that. I think we can tease out some of the agronomic management impacts, but above and beyond that, we'd want to look at the soil health, and we just would need many more data points to really start to get a handle on how soil health measurements start to impact tile water quality. Lastly, and I think this is one of the most important parts of our study, is we were looking at our intensively monitored sites where we're getting really high quality data from, we also bi-weekly sampled these sites. So our question was, could we go out and take bi-weekly samples and get as good of nitrogen or nutrient concentration as our really intensive flow-based monitoring automated systems? And it turns out for sediment, the relationship wasn't great. If in a perfect world, we'd hit this 1-to-1 line, so our biweekly average would equal our flow weighted mean concentration, which is our real high quality number. And for soil or sediment movement, I think what we're seeing here is when we're out taking biweekly samples, they're not triggered by rainfall events or anything like that. So we're missing most of the high flow time periods with our biweekly samples. And so we're not hitting those higher sediment loads or sediment concentrations in our biweekly sampling. Similar results for phosphorus and dissolved phosphorus, where our flow weighted mean concentrations were a tad bit higher than our biweekly averages. The great thing about this was our nitrate was spot on. So if we're out and if you're interested in knowing nitrate levels of your tile systems, of your fields, if you have a project looking and assessing nitrate movement with tiles, I think you can do a really good job. I think this data shows that you can do a really good job of getting your average nitrate levels through your tiles by just going out and taking biweekly samples whenever the tiles are flowing. That relationship is pretty solid and very close to that 1-to-1 line. So just to wrap up, we're looking at a big picture. Nutrients, we're more concerned with nitrate compared to phosphorus and sediment when we're looking at tile systems. When we're looking at nitrate movement and assessing nitrate concentrations in tiles, it's really important to assess our levels and look at our cropping systems and nitrogen management to really decrease the risk of nutrient or nitrogen movement through the tiles. And lastly, if we're looking at categorizing our nitrate levels in our tiles, biweekly samples are going to do a really good job at that. So with that, Warren, I'll be able to take questions and we can open it up for questions for everybody.
Yep, very good. And yes, I'd invite Eric and Aaron, if you're able to chime in on any of these questions as well, to go ahead. So the first one is a carryover from our last conversation. So we talk a lot about nitrate concentrations and their correlation to flow. At some point, wouldn't the real concern be about the total amount of nitrate being discharged? Can you talk about that, Tim?
Yeah, and I think I hit on that a lot in my presentation. So that is the concern, the thing that we're looking at in particular is the amount of N being discharged. The amount of N typically, as our flow goes up in our tile system, so does the amount of nitrogen lost on a pounds per acre basis. However, we can't really impact all that much the amount of flow we get in these tile systems. It's pretty much up to how much rainfall we get in the certain landscape that we're in. What we do have control over when we're managing our farms and fields is some of our agronomic practices and our nitrogen management practices. And really those can impact the concentration of nitrate in that soil profile and in turn impact the amount of concentration of nitrate in the tile systems.
Very good, thank you. And I can handle the next question. Question is about Farm Fest, which for those who aren't familiar, Farm Fest is an outdoor ag trade show that happens in southwestern Minnesota every August. It happened for more than 20 years consecutively, did not happen last year due to COVID. And I'll answer this question by saying, yes, I think it's going to happen this year. And yes, we will. The MAWRC will be there with our with a booth, and that will include we'll have our nitrate analyzer on hand. And so if people want to bring either a sample from their well if they have concerns, or from a tile if they'd like to know what's in their tile water, they can bring those to our booth, and within 15 minutes we can give them an answer. So thanks for that question. Next question. Nitrate concentrations in Discovery Farms tile data are much lower than the expected based on a Purdue University interpretation of nitrate concentrations in tile that is often referenced. And I know, Tim, we've used that piece as a reference as well. Any thoughts as to why our numbers are lower?
Yeah, that's a great question, Greg. And I don't know, in my interpretation, if we're looking at that Purdue University document is just referencing corn soybean rotation type fields. And if we look at our data, just looking at the corn soybean type rotation, our middle part of our data set, our median is anywhere from 10 to 20. And that is what they identify as being a range where your nitrogen management is really doing a good job, about the best you can do. With nitrogen management, you can expect 10 to 20 milligrams per liter nitrate in your tiles. So I think where ours vary is we have different crop types as well. So if we're getting alfalfa into that system, we're going to see lower values there as well, and in turn other cropping systems as well.
Very good, thank you.
Well, Tim,
next...
one other quick thing I'd just like to mention too, with some of the Wisconsin data, that we really did see a flow component with some of those where Aaron showed those three sites that we had really high flow. The nitrogen values were extremely low in some of those, unexpectedly low and very consistent, likely because of that just large volume of flow that was coming through those tile systems as well. So that is also a small factor that can influence those concentrations.
Very good, thanks, Eric. Tim, can you break out the corn data by silage corn, corn for grain, sweet corn, and ethanol production?
Yes, we can break it out by silage and grain. We only had one sweet corn field, so I didn't include that. Ethanol production, I don't know why, that probably wouldn't be much different than grain production. So I would guess we'd just include that in the grain section. But for all the corn years that in my analysis I just showed, it combined the silage and grain aspects, or grain fields. So
okay, very good.
I didn't see much difference between the silage and the grain.
Okay. Were there differences in timing of N application, fall, spring, or side dress?
Another great question. And I looked at this. Unfortunately, we just didn't have enough data points, and there's too much scatter in terms of management practices to really tease that out. I think that's something that's better answered by, you know, a university type research farm where they have more control over their management practices and can have much more replication of those sorts of timing impacts of nitrogen application.
Next question, how much variability was there in the soil health measures?
Lots. In particular, the physical measurements. We really have a hard time with those, and variability throughout the field. And it tends to be a hard thing for us to get a handle on. In terms of the chemical analysis, there was some variability. I don't know how much, if it's considered a lot of variability or a little variability. That is something we're going to have to assess with Matt when we write a full report for this project.
Sure. Next question is a clarifying question, Tim. So you had mentioned that samples were conducted in June, and I think you're talking about the soil samples and not water sampling, which was sort of year round. The question is, was there any correlation between manure application and spikes in total phosphorus and nitrates in tile drainage?
Yeah, so our soil sampling was conducted in June, but our water monitoring sampling, as you said, Warren, was year round. So there, in a couple of instances, and it's on a site-by-site basis, we did see some correlation between like a manure application and spikes in phosphorus. In particular, Aaron had some of that data that we just took out due to time constraints of the webinar. I don't know if you could add anything to that, Aaron.
Yeah, I mean, we could always kind of see a little bump during those like side dress time periods. It may or may not be all contributed to the nutrient applications, but when we saw the big spikes, like in the phosphorus, that was a case of manure being spread, you know, the day before it was sampled or 2 days before it was sampled. We saw a really big nitrate spike, and that was, again, a couple of days before sampling, and there was a big rain event at that time as well.
Very good, thank you, Aaron. Next question, increasing soil carbon via soil organic matter as a soil health metric requires also a 3 to 4-fold increase in organic nitrogen, which is a multi-year process. Are any of these sites going to be long-term sites, 5, 10 years or more? And to help get at that question.
That's a great question, Mark. Unfortunately, this project wrapped up, so all these sites are now done monitoring. But I think that it was one of the reasons why we didn't see much correlation between our soil health measurements and our water quality metrics. I think like you say, it's a long-term process, and I don't think any of our sites were in that long-term situation where they've been practicing a lot of these soil health practices for 10+ years. So I think that was a limitation of our study and our sites.
Very good. And did you do any analysis or comparison between tillage and no-till and how they affected nitrogen or phosphorus loss?
I did look at that on a big level across all our sites. I didn't find anything that was consistent. I think we need to go in and more regionally look at that. I think that might vary more by region. And we'll just have to see if we have the right combination of tillage and no-till sites to come up with anything. Mm-hmm. But very good point. Very
good. And you may have talked about this already, Tim, but you presented a lot of tile nitrate concentration information, and we talked about converting that or the importance of ultimately getting to loads. But did you share any load data today?
I didn't share any load data. We have lots of load data that we can talk about. I wanted to focus on nitrate concentrations because a lot of times our nitrate loads in our tiles are heavily dependent on the amount of flow. And that's not really something we can have much of an impact on with our ag management of our fields or things like that. It's a lot of times it's really heavily related to the amount of rainfall, and so if we're focusing more on nitrate concentrations, those are really more impacted by management practices.
Okay, and speaking of those, you showed a slide talking about tile concentrations, comparing cropping systems with and without cover crops, and the nitrogen concentrations were lower in some systems with the cover crops. Wouldn't that be considered a potential soil health benefit?
Yes, I think that's true. Soil health in general is more than cover crops, and when I'm talking about we didn't see any impact, this was all based off of trying to quantify soil health through these different measurements. And so in general, I think that the point he raises is right. We just weren't able to quantify that with soil health measurements.
Very good. The next question, can farmers make adjustments in their end management based on the sample results from a biweekly sampling for that current year or the following years?
Yeah, another great question. Thanks, Mark. I don't know about current year. I wouldn't even try for current year. Maybe following years. I think the best approach would be to quantify your fields, and over a longer time period, if you see you're consistently on the higher end, trying to make some changes to your nitrogen management to bring those levels down in your tiles.
Very good. The next comment, great work. The conclusion that you reached on using biweekly sampling for nitrate concentrations, would that apply to nitrogen loading as well?
Nope, that would not apply to nitrogen loading. I think we found through the study, if you want to get a really good nitrogen load, you have to have really good flow monitoring, because flow is a very difficult thing to measure. And Aaron showed some of the limitations we had with the biweekly type of flow sampling that we did. Having a continuous system that has built in for if we're going to have pressurized flow through these tiles, so backwater conditions, having good flow monitoring is essential to get that end load. If we're just looking at concentrations, biweekly samples are a great way to do that.
Okay, and this will be your last question, Tim. You talked several times about how we need more sites and more data to really find the correlations to some of these soil health measurements and water quality. So what are the future plans? Will there be an extension of some of these sites or next steps?
I hope so. That would be dependent on us finding more funding to continue this type of work. But I think we've learned a lot from this project and could continue that learning with another project along the same lines.
Very good. And a couple more questions have come in. I'm going to take the moderator's prerogative and keep us around another minute or two. First of all, from your experience, Tim, do you have an opinion about what might be a valid, reliable soil health test?
Another great question, and I am not a soil health expert. So I don't think Matt's on here, but I don't know, Amber is not on here either. But what we've been looking at lately has been like a POC measurement, which is like a potentially oxidized, I forget what the abbreviation goes to, but there are a couple of measurements that we're really focusing in on now in terms of they've collected a lot more data on these different measurements, because there's lots of them. So there's your options are I don't want to say unlimited, but there's lots of different options. So I can follow up and find out more about the two specific ones that we're looking at more thoroughly going into the future.
Thank you for that. And then the next question, AdaptN is a nitrogen modeling software that will estimate nitrogen losses due to rainfall. Was that software used on any of these sites?
Nope.
No, okay. I did not think so, but just wanted to be sure. And then, so the last question as we wrap up here today, I want to thank all of our presenters. I also want to thank all of our supporters and those who made this project possible. I should mention also a huge thanks go out to all the farmers who allowed us to do this work on their farms across the 2 states. With this edge of field on-farm monitoring wouldn't happen without their participation. Where can you find this after today? This presentation has been recorded and you can find it at the MAWRC YouTube page. And so I'd encourage you to go there and subscribe, and you'll find other videos on past events that we've done as well, and share that with others who weren't able to be with us today. And with that, I think we will call it a wrap, and thank you all for joining us, and we'll look forward to visiting with you next time. Oh, sorry, I forgot, Erica. We have a quick, before you sign off, we have a quick survey or poll that we would like you to answer. You've seen that now, and we'll give you just a minute or so to zip through that.
And then also, Warren, I will send out an email with a link to the recording for all the registrants. So if you're having trouble finding our YouTube page, you will get an email with the direct link to that.
Thanks, Tim. So again, thank you all for joining us. Look forward to other events as we create more virtual events, and later this summer, hopefully get back to doing some in-person field days, and we'll see you all at those activities as well.